Hello again, this is building an iOS app with C Sharp, Module 5, Video 5. In this video we're going to design and build out our execution context model class. Okay, so we've already got an execution context class. We created that as part of creating the action class, but of course it's empty at the moment. So what we're going to do in this video is fill this out and write tests for it. So to begin with, let's think about what an execution context actually needs to what behavior it needs to give us. First and foremost, we need to be able to track progress so that the higher levels of the application can give feedback to the user of where they're up to in the exercise program. It also needs to support cancellation so that if the user stops their exercise program early or they exit the application or whatever it might be, we can cancel that execution cleanly. And we also need to be able to pause because if someone's knocking on the door, you need to stop your exercises momentarily, then that's where you would hit the pause button and then come back to it later and hit play again, and you would pick up from where you left off. And finally, we want to be able to start the execution context from a specific point in time, just because that means that if the application gets tombstoned when the user's midway through an exercise program, we can remember where they were in that program, and then the next time the application is rehydrated, we can pick up the exercise program from that point. Not strictly necessary; it's just a nice to have. We may as well do it if we can. So I'm going to aim for that as well. Now, to start with, we're going to be using Reactive UI at this point because we want to leverage some of its functionality in the implementation of this execution context, as we'll see shortly. And as a result, we're going to have a bunch of disposable bits and pieces that we need to get rid of, but we also need to inherit from reactive object. Our execution context needs to inherit from reactive object. So what we really want is a disposable reactive object. And you've probably recall that I created a disposable base class. What I'm going to do is create a disposable reactive object class as well. And of course we need to add reactive UI to our packages. And since we're going to be leveraging reactive UI from our models layer, we'll also need to add the package there. And finally, we need a reference to our utility project from our model layer. So given that, we can inherit from our disposable reactive object. And in terms of a constructor, what I'm thinking is the only thing we'd ever want to pass in is some time span with which to skip ahead, which will default to 0, of course. So this will allow us to skip to a certain point in the execution of a exercise program. Let's also create our test fixture. Right, and as a starting point here, I think I will tackle the cancellation behavior first. So just thinking of the API we're going to want, we need something to tell us whether the context has been cancelled. Let's just stub this out to return false for now. And notice I've only got a getter here, no setter, because it doesn't make sense to uncancel. Once you're cancelled, you're cancelled, that's it. So it's a kind of a one-way operation. And that would be instigated by this, I guess I'll call it cancel method that we can call. And the other thing I think we'd want is the actual underlying cancellation token, so that we, given an execution context, we can just extract that token and pass it into async calls that expect a token. Okay, so let's write some tests around this this functionality. First things first, let's make sure that when we call cancel, it actually cancels the cancellation token. We're actually kind of testing two things here, but we're testing the is cancelled property in conjunction with is cancellation requested. Maybe that's not okay, maybe it's fine. They are closely related. I'll do that for now. What else do we want to test? So we want to make sure that when we cancel, not only does is cancel change to true, but it also raises the property changed event, because probably we'll need that for not directly binding against, but the VM layer, the view model layer, will likely propagate that through to the view layer. So it is useful to know when that property's changed without having to poll it. Okay, we're going to need reactive UI in our unit test project as well, if we don't already have it, of course. So all I'm doing here is hooking into this is cancelled property changed event using reactive UI's helper method. And when that gets called, we set this called to true. And of course, I'm making sure that it's false when we start, and then once we've called cancel, we make sure it's true. So that's probably a good starting point to test from. So let's just make sure we can execute, or we can build and make sure that these tests are failing. Right. So 3 failures. Not expecting this one, are we? Okay, looks like we've introduced a different problem by referencing reactive UI. We'll have to look at that later. It's not the, that's not related to this execution context work, other than the fact that we've added a reference to reactive UI. Okay, so these are failing. That one's definitely failing as we'd expect. This one is not, so maybe this is the problem. You are referencing the portable version of reactive UI in an app. Well, it's because we need to add the reactive UI package to our test harness rather than just to our unit test project. And reactive UI does this bait and switch technique, where if you're referencing it from a PCL, then you just get kind of the bait, really. It's just kind of the API rather with no implementation in there. You just get basically the skeleton of reactive UI's API surface, whereas when you're referencing from an actual platform specific project, you'll get the implementation specific to that platform. And because we haven't done that, it's not found that implementation, so therefore it's fallen over. So we need to add reactive UI here as well. Okay, so now it's failing as we would expect. So let's look at the implementation of this. So clearly we're going to need to get a hold of a cancellation token, and the way we do that is with a cancellation token source. Like that, and then we can simply return the token from that source here. And to determine whether we're cancelled, we can use the source as well. And finally, cancelling should just be a matter of requesting a cancellation on the source. Thusly. So let's try our tests. Yes, we have not done anything here to make sure that changing is cancelled will raise a property changed event. Right, so there's various ways we could do this. I mean, the really simple thing to do here would be just to say raise property changed here is cancelled. And that should fix our test. So I'm just wondering whether we should do something a little cleaner, little more reliable, robust than that. And frankly, a little more reactive than this. To me, it kind of makes sense to have a subject of unit called cancel requested. And then hanging off that, or derived from that, we can have an observable as property helper for is cancelled. So let's see how this plays out, see if this is cleaner. Let's put this first. I think that makes sense to have that first, and then cancel requested is just some subject, and then is cancelled gets set to true whenever cancel requested has anything tick on it. So now is cancelled just needs to return is cancelled dot value. Cancel just needs to tick a value into our cancel requested subject. Finally, we need to hook into whenever is cancel changes to true, we need to run the appropriate logic to actually instigate the cancellation. So like that, which means we don't need to manually raise the event or cancel the token down here. So that should be a working version as well. It works. Now, of course, we've not correctly cleaned up here, so let's just add our disposal logic. Right, so that I think covers cancellation. Let's move on to support for pausing. And the API we want there is just going to be simply, the ability to get or set a value indicating whether we're paused. And in addition to that, if you think about what actions are going to need to do when the execution context has been paused, they're going to want to wait asynchronously until it's unpaused. Now, we could have each action figure out how to do that themselves, or we could provide a helper method on our context. And that's of course what I prefer to do. So that would look like that kind of API. And let's just stub these out again and write some tests. It's not a whole lot to test with the isPaused property, but it's driving the behavior of the wait while paused method, which is where the real work is happening here. So let's test that. Let's just say it completes immediately if it's not paused. I think the best way to make sure this is to grab a hold of the task and just to make sure that it's completed as soon as we've grabbed it. Okay, so next up, let's make sure that when we call wait while pause async, it actually waits until it's unpaused, which is the whole point of the method. And unfortunately, I don't think we can do this without blocking for a little while, which is not ideal, but we can just choose a very small time span or time period to wait here, which is, of course is a very long time in CPU terms. So we still have a valid test here. It's just that it's probably running a bit longer than I would have liked. So all we're doing is we're starting off with a pause context. We are waiting. Sorry, we are calling this wait while pause async method, and then we're waiting for that task to complete for 10 milliseconds, and we expect that not to complete because we're still paused. So then we unpause and then wait again, and this time we do expect it to complete. Okay, now finally we want to make sure that if something's waiting and the context gets cancelled, then so too does that wait operation. Okay, so just to explain here, we are starting off with a pause context again. We're calling wait while paused async to get our task. We make sure that it's not completed just by waiting on it for 10 milliseconds again. Then we cancel our context, and at that point we expect our related task here, or not our related task, we expect our wait while paused task to also be cancelled. So we wait on that for half a second, but actually we don't expect it to take anywhere near that long, because we expect very quickly to get back a cancellation, or sorry, a task cancelled exception, which will actually result in an aggregate exception just due to the way the TPL works. And inside that aggregate exception, we'll find our task cancelled exception. If this catch block doesn't run, then we'll fall through to this assert.fail call, so that our test will still fail. Alright, so I think that's a good set of tests to run with for this functionality. Let's try them out, make sure they fail. Okay, so interestingly, of course, this one succeeds because at the moment we're just returning task.fromResult, so that's kind of expected. The other two are failing as we had hoped, so let's look at the implementation now. So first of all, isPause can just simply be almost just a simple property, except because we're in reactive mode here, we need to ensure that when we set it, we actually raise the property changed as well. And using reactive UI, that's quite simple. We just call this raise and set if changed method. Give it the backing field and the new value, and that's it. So the real work here is inside this wait while paused async method. And to implement this, we can just move from the reactive world into the TPL world by using our toTask extension method. Not our toTask extension method, the toTask extension method provided by Reactive Extensions. that means we need to know what observable would tell us when we're no longer paused. And that's pretty simple. We know that we have this is paused property, so we can just hook into that. Whenever it's not paused, and we only care about the first instance of that, because as soon as it's unpaused, then this task will unpause, and we convert that to a task. And notice that this toTask extension method can optionally take a cancellation token, which is perfect for us because we've already got a cancellation token encapsulated by this execution context. And we know we're going to cancel that when cancel gets called. So by using that same token, we also ensure that this task will get cancelled. So that should be enough to fix those tests. It is. Again, please just ignore this failure in the state service. I will get to that after this video, I think. Okay, so let's look at progress, how we track progress, how we skip ahead to a certain point in the execution context or in the exercise program, and also what we're going to expose in terms of this is where we're up to. What exercise are we up to? What set are we up to? What rep are we up to? That's all got to be exposed through the execution context. So in terms of the API, we probably want, or we'll definitely want a time span telling us our progress. And I also think it'd be useful to have a time span that tells us the progress through the current exercise. So this progress here is the progress through the entire exercise program, but it would also be useful to know how far we are through the current exercise. Now something needs to tell the execution context where we're up to, that we're progressing through the exercise program, because the execution context doesn't really know this. It's just kind of a state bag, if you will. It holds the state, but something needs to tell us that we're actually progressing through the exercise program. So we need some kind of way of doing that. And at this point, I think it's going to be the exercise model object itself that is making these calls, but that's not the point right now. That's not what we need to figure out right now. What we need to ensure is that we have a way of doing that. So this is what I'm thinking is we'll have this add progress method, which just takes a delta as a time span, and the execution context can use that to kind of increment through or progress through the total progress and update any these two progress properties here. And I also think we're going to need to be able to set the current exercise, set the current set, or set number, let's just call it set, and finally set the current repetition. Now we don't have an exercise model yet, so we'll just stub that out. We'll just create that class, the public class, and that's of course something we'll come back to in a later video. Now I didn't actually create properties for these things, so let's do that. Because that's roughly the API we're going for. I think I'm going to come back to this skip ahead thing, and rather than trying to do this all at once, let's see how we go with the test, see how intermingled this stuff really is. Okay, so first of all, let's make sure that adding progress actually updates our progress property. And of course, because it's internal, we need to ensure that our test code can actually call that. And to do that, we can use internals visible to. Okay, so we're just making several calls against add progress and then making sure that our progress property is the sum of those calls as we progress through. Next up, let's make sure that it also adds on to the progress of our current exercise. I'm going to start off with this, but I've got a feeling we're going to have to change this because we haven't actually set a current exercise, and I suspect that once we get into the implementation here, that is going to drive, it's going to have a consequence for this property, so we'll see how we go. I'm fairly happy with those two tests. Other than that, we'll test this stuff. Well, not sure we even need to test that yet, but let's try this out. Righto, so two failures as we expect. So let's take a look at the implementation here. I think the simplest way to tackle this is to have an observable of deltas that we are ticking from this method, and then we can use that to calculate the other properties. So here's what I mean by that. So based on that observable of progress deltas, we can hopefully figure out the current progress and the current exercise progress. Okay, so we're taking the deltas, we're using this reactive extension scan method to keep a running tally of those deltas, and then we're using reactive objects to property method to convert it into a property. And so all we need to do is return that from here, or return the value rather, and that should give us the right outcome for progress at least. Let's try our test. Okay, good, so it's working. So let's do a similar thing for the current exercise progress. Except in this case, we need to know when to reset it, which is, you know, what I kind of alluded to when we're writing the test. The trigger for resetting here is when the current exercise changes. So obviously when the current exercise changes, we need to reset the current exercise progress to 0. So we need to watch the current exercise property to know when that's happened. And whenever that changes, we'll select a new observable to switch to. Okay, so just to explain again, whenever the current exercise changes, we select a new observable, and that observable is progress deltas. We start with 0 because we're resetting, and then we do use the same technique as we did above here, but we're only summing up values from that point onwards rather than since the sequence began. So we switch that observable and then we use to property to convert it into a property again. Now, this, I think we'll fix the functionality, but our test should still fail, I think, at this point, because we've not set an exercise. Or maybe it will work. Yeah, it works because it doesn't really care if the exercise is null. So actually, I think what we need here is another test to say when the exercise is changed, it does reset back to 0. So let's do that test. That test should fail. We'll use this as a starting point. Okay, so now we start off with a null exercise. Let's actually start with a non-null one, because that's more realistic. So we add some progress to that exercise. We expect it to increase to 100 milliseconds. Then we swap out for another exercise, and we expect it to reset back to 0. And just for good measure, we add some more progress and make sure that it's 150, not 250. And that one is failing. Expected 0, but was 0.1. So obviously this one here is failing. So I'm just back from debugging, and as you can see, I've just added some do output here to our pipeline to try and figure out what was going wrong. Turns out I'm being stupid. We've actually forgotten, or I've forgotten to do anything when we call set current exercise. So what was happening was it would, when we were calling set current exercise, it wasn't actually doing anything, so the pipeline wasn't resetting as we were intending. So let's flesh this stuff out as well. Okay, and all we need to do now is set that. Now, I wouldn't normally jump ahead here, but I don't think we're going to end up testing this stuff, quite frankly, or at least not in this video, so because it's already running for quite long. So I'm just going to set these, and I may add some tests later. Hopefully that is enough to get us running. Okay, great. Now we are passing. So the last thing I want to support in this execution context is this idea of skipping ahead, which we talked about before, but we've not really done anything with it yet. And the way this is going to have to work, I think, is the kind of governing view model, the main view model that's kind of rehydrating the application, will store and retrieve the point in time at which the exercise is up to when the user kind of exits the application or whatever. And then, of course, the next time the app starts, it will pass that skip ahead value into this execution context constructor. But the execution context can't really do much with that except give it to other components in the model so that they can know what to do in terms of where they should be skipping ahead to, because you could be part way through a given action, for example. So it's not like the execution context can really know that. So the way I see this working is for the execution context to just expose skip ahead as a property, and then other components in the model can use that to say, oh, I'm supposed to actually skip ahead at this point because that's non-zero, or it's more than 0. And so they can skip ahead as much as they can and then tell the execution context to kind of fast forward to that point, which will in turn reduce the value of the skip ahead property. So that's, I think the only property we need here to write our test is the skip ahead time span. And let's just start with some tests to try and solidify this. So the idea would be that when we add progress, we reduce any outstanding skip ahead. So let's manifest that with this test here. And we'll start with some value for skipping ahead. Let's just do 3 seconds. And we'll make sure that we see that 3 seconds as the initial value of the skip ahead property. And then as we progress through, or as we add progress, we expect that skip ahead value to reduce. Let's just do a few different calls here to make sure it's working as we expect. Like that. And if the skip ahead is already 0, we just leave it at 0, right? We don't want to go under 0, it kind of doesn't make sense. So let's test that as well. Okay, so there's our 2 tests. Let's make sure they fail. Yep, they're failing. Good. So let's have a look at the implementation. And again, I think this is going to be a case of this using this scan technique and a backing property, which we can call skip ahead. We want to start with the value that we're passed in here. And as we get new values, we subtract off, as we get new deltas, we subtract them off the skip ahead value. And of course, we need to make sure that we don't go below 0. That should do it, and of course we need to use that backing field here. Like that, so let's try our tests. Cool, so we're passing. There's one more thing I want to do here before finishing up this video. I was debating whether to do it here or just kind of do it separately and then explain it afterwards, but it's kind of important, so I'm going to do it as part of this video. What I'm going to do is add this helper class that I've used, that I've written in the past for my other project, that just really helps with disposables. Let me just add it and then I'll explain it after I've typed it all up. Okay, so that's the method I wanted to add, and well, sorry, I'm missing one thing here, which is to make sure that T is disposable. So the idea is you take any disposable object and you've got this extension method called addTo, which can add it to a composite disposable, which is a reactive extensions, really useful reactive extensions disposable type, which has any number of other disposable child items, so that when you dispose of the composite disposable, it disposes of all its children. And I've stuck that in the same namespace as composite disposable, so that whenever you've imported composite disposable, you're also going to or we're also going to get this add to method. Let me show you why that's useful. Okay, so by virtue of using this composite disposable, we get this add to extension method on anything that's disposable, and we can just simply add it to our disposables, and then in our dispose logic, we don't have to keep coming back to it and thinking about it separately. We just dispose of the one thing, and then we make sure that whenever we've got something that needs to be disposed, we can put that in line in this fashion. For example, that just about everything here is disposable, so it just makes it easier when you're writing this logic. Okay, and finally let's just run the test again just to make sure we haven't broken anything. And we're all good. So that was execution context. I think that's going to get us everything we need. It's obviously hard to know for sure, but based on the overview I did for this module, I think this will get us at least 95% of the way. We may have to tweak a few things as we go along. And it's probably the most complicated part of the model. Exercise may be a little complicated, but I think this is the bulk of the complication. So hopefully, subsequent videos will be a bit quicker. Anyways, I will catch you in the next one. Cheers.